Welcome to the lecture Scientific Data File Formats. Today I'm going to talk about NetCDF and the Plot3D. This is the second and also the last part of our data file format lecture. What is NetCDF? It is a format that is widely used by people in geoscience education and research community. It was created and supported by Unidata, part of University Corporation for Atmosphere Research, or UCAR. NetCDF is a popular file format. It is very flexible and also it is self-describing. By that, we mean a lot of important information such as the dimensions, the variables, and some detailed information related to the dataset are all described inside the file so that the file format can be used by many different applications for different needs. Information related to the data can be found in the file itself. NetCDF is not just a file format, it actually is a software library. So it has a set of tools allow you to create, access, and also share array-oriented scientific data sets. NetCDF has two data models. One is we call classic data model, which was supported before NetCDF 4. And we have a more modern data model called enhanced data model, which was supported starting NetCDF 4. In the classic data model, it contains the most essential information for multidimensional array. Variables are the actual data in the array. Dimensions records the length of your array. It can be 1 or 2 or 3 or more dimensions. And also, it has attributes. Attributes are the information you use to annotate the variables. Starting from NetCDF 4, they adopt an enhanced data model. Basically, it has everything that was in NetCDF 3, the classic data model, but they added the concept of groups. That is, you can have multiple groups of variables, and within each groups, you can have your own dimension, attributes, etc. Also, it allows user-defined data types. One such example is so-called compound data type. That is similar to what you define struct in a C language. A data structure that contains multiple components, and each component has a different type. These new features supported by enhanced data model are now used with NetCDF 4 and also HDF 5. Now let's look at NetCDF classic model in more detail. The reason I talk about NetCDF classic model is that the enhanced model essentially contains everything that the classic model has. The classic model also contains the most essential information about the multidimensional data arrays. So it has 3 components in the classic data model. The first is the variables. NetCDF essentially is to store multidimensional data arrays. The variables are the actual arrays of data. It can be one of the 6 types such as char, byte, short, int, float, and double. These are the example of a NetCDF file can contain temperature, pressure, and velocity. Now for the data arrays, you have to store the length of the dimensions. For example, here we have longitude, altitude, and latitude, and the lengths are 25, 10, and 30. So you need to store those information in the file. So essentially, the dimensions describe the axis of the data array. Each dimension has a name and also a length. A dimension can be also of unlimited length, which means you do not have to declare the length in the beginning. The array along that direction can be extended after it is created. In the classic model, it can only has at the most 1 unlimited dimension, but later in the enhanced model, that is NetCDF 4, can have multiple unlimited dimension. To describe what the dataset is all about, you can have attributes. So attribute is to annotate the whole file. We call that sometimes global attribute. And also for each individual variable, you can have its own attributes. One example of that is you can store the unit variable. So for example, when it comes down to temperature, you can store whether it's Fahrenheit or Celsius. The attribute can be just a text, or can be scalar values, or a one-dimensional array. And also, an attribute can be associated with a variable or with the entire file. This is a diagram of the NetCDF classic data model. You have file will contain variables, which are the essential data arrays. Also, it has dimensions to record the length of the multi-dimensional data arrays. When you have multiple variables, they don't need to have the exact same dimensionality. That is, each variable can take a subset of the dimensions and define values within. And you will have attribute. Again, attributes are to annotate the file or individual variables. Now let's look at what's in the enhanced data model. So starting from NetCDF 4, you use something called common data model. Basically, the most important concept in this common data model is that a file can have multiple groups. Starting from the root group, it can have multiple other groups as well. And within each group, you have the same information stored in the classic data model. Although in the classic data model, you can only have one group. So now in NetCDF 4, you can have multiple groups of variables, dimensions, and attributes. Besides that, the user can also define more complex data types for each of the variables stored in the array. Again, this user-defined data type can be considered as a struct that we use in the C language. This is the diagram that I used to show the enhanced data model. So you can have multiple groups. Within each group, you have the same information stored in the classic data model. Now, the variable in the enhanced data model can be more complex. Like I say, can have a user-defined type. And also, the enhanced data model supports more primitive data types. So this slide points out the advanced NetCDF 4 features. First of all, it has better interoperability. That is, it can read and write other file formats that use the common data model. One example is the hierarchical data format, HDF5. It allows multiple unlimited dimensions. Remember, unlimited dimension means you do not have to give a specific size for that particular dimension. In the classic data model, you can only have at the most one unlimited dimension. Now you can have multiple. And again, we talk about groups. A group is like the concept of folder. You can organize your data hierarchically. It allows compound data type, like the C structs. And also it supports many other features. Details can be found from the documentations for NetCDF 4. So remember I mentioned NetCDF is not just a file format. It is actually a software library that allows you to create and read NetCDF file. It is also self-describing, meaning you can describe the information about the dataset in the file. So if you encounter a unknown NetCDF file, so in order to read all the data out, you need to query the information. On this slide, I show you the important C function that you can use to query the essential information. Just to recap, remember NetCDF has variables, dimensions, which is the length of the multi-dimensional data arrays, and attributes. Here, let me just give you a summary of the important method that you can query those information. First of all, of course, you need to open the file. Now, in order to prepare the multi-dimensional array, you need to query the number of dimensions for the variables stored in the dataset. And each dimension can have an ID. So you're using this NC-INQ dim IDs function. In NetCDF, all the query method will have prefix INQ, followed by different names depending on what information you want to query. So after you get the number of dimensions and the IDs, you can query the name and the length of each dimension. In NetCDF 4, you can have multiple groups. So in order for you to read all the variables out of those groups, you need to query the number of groups. And also each group has a name. So you can create a name, and then later you can use a name to perform other related queries. Remember, attributes are used to annotate file and variables. So to get information about the file, you can first of all query the number of attributes and then call corresponding method to get the specific detail in the attribute out. Now, assuming you already know the number of groups, which we have already queried, if you want to read all the data of the file, then you loop through each of the groups. Within each group, first of all, you query how many variables are in the group. This is because a group can have multiple variables, and each variable will have ID. Now, you can get information for each variable. You could get the variable name, the type of variable, and also the dimensionality of the variables. Like I say, each variable can be defined under a subset of dimensions. So you query, first of all, the number of dimension, and also the corresponding dimension ID that are used to define this variable. A variable can have attributes. So you can query for each variable how many attributes it has, and for each attribute, you can query the name and also the content. Finally, after you read all the information out, you are ready to allocate space, assuming you're using C language, and read the data out. After you're done with that, you close the file, you're done. In this slide, I show you information related to installing NetCDF. NetCDF is compatible with Windows, Linux, and Mac. So please go to the website list here for detail. One thing I want to mention that is for NetCDF 4, because it depends on the common data model, which is defined in the hierarchical data file HDF5. So you need to install HDF5 first before you can proceed to install NetCDF. Also, after you install NetCDF, you're going to find there are a bunch of tools for you. For example, NetCDF file is defined as binary. If you want to see the content of the file, you can run a program that should be installed with your NetCDF package called ncdump. ncdump convert a binary NetCDF file into a text-oriented CTL file. So actually, when you run ncdump, you are going to see the text that will give you all the information about the dimensionality, the dimensions, the attributes, etc. Also, if you have a CTL, which is text-oriented file, you can run ncgen to create a binary NetCDF file. NetCDF also has a viewer. There is a Java-based visualization software called IDV, the Integrated Data Viewer. So if you have a data file, a NetCDF file, you want to look at it, you can use IDV to see what's in the data. And also there's another program called NCView, which is a quick and easy visual browser for NetCDF files. Okay, so that's all I want to talk about NetCDF file for now. On the class website, I'm going to play some sample programs that are used to read information from NetCDF files. Hopefully those examples will be useful. Now let me move on to talk about the last file format I want to mention. That is the PLOS3D file format. So PLOS3D file format was created by NASA Ames Research Center, and PLOS3D was a common software that a lot of computational fluid dynamics people are using to analyzing their simulation results. So PLOS3D even now is still a very popular and the standard file format, in particular for computational fluid dynamics simulation. So plus3D file format is a very simple format, and also is very compact. It allows you to store single or multi-block structured grid scalar and vector data. It doesn't have a lot of fancy structures, but it's very simple, so it is very easy to use. Typically, a plus3D dataset will contain a grid file and also a data file. The grid file often has a .x extension name, and the data file has .q extension name. So now let me briefly talk about the grid file. A lot of CFD simulations use curved linear grid, which is a structured grid. However, the mesh are wrapping around the object on the simulation. Because of that, you have to store the position of every grid point. So here is the grid file format. First of all, you need to give it dimensions for the structured grid mesh. It is assumed that it is a 3-dimensional domain, so you need to give the dimensions for I, j, and k. Then you need to provide a sequence of the positions for the grid points, assuming n is the number of grid points, which is the product of I dimension times j dimension times k dimension. Then you are going to provide a sequence of x positions for the endpoints, followed by a sequence of y positions, followed by a sequence of z positions. So you can imagine you're going to read a chunk of x coordinates for the point, and then y coordinates, and then z coordinates. About the attributes, so plus3D store the attribute in a different file. Often it has a name of a .q file. It can store scalar and a vector. So meaning you cannot have a very complex compound data type for the attributes. For scalar, it simply store n attributes, one for each grid point. Here again, n is the product of the ijk dimensions. If it's a vector file, then you're going to store n vectors. And then the vectors are stored as x components first, followed by y components, followed by z components. Here the x, y, z are the vectors. So again, just like the positions, you're going to read a chunk of x component for the vectors, and then y components, and then z components. Noting that this is not always the most efficient way to store the data, because for every point, if you want to get the vector, you have to get a value and have a long jump, and get a y component value and have a long jump, then have a z component value for a long jump. So people later have proposed some more efficient way to store the data we call interleaved way. That is, you store x, y, z, x, y, z, x, y, z. But those are not standard plus3D file format. So here I only talk about the standard. Now, for most of CFD simulations, they produce 5 fundamental scalar variables. And this is actually the name Q come from. So the 5 variables are density, momentum. Momentum is a vector, so you have an x momentum, y momentum, and z momentum, followed by energy. So you have Q1 to Q5, 5 variables. And also you could have some attributes about the simulation. For example, the free stream Mach number, the angle of attack that you are trying to simulate, and also Reynolds number and the integration time. So basically the format for the more general 5 variables .q file, you're going to first of all specify the dimensions, idim, jdim, kdim in the example. And then you put the metadata, the attribute, the Mach number, the angle of attack, and the Reynolds number and integration time. And then you store a chunk of first scalar, the density, followed by a chunk of second scalar, x momentum, and then y momentum, then z momentum, and then energy. Here, a chunk, n scalar values corresponding to the number of grid points. Okay, so as you can see, the plus 3D file format is very, very simple, but it's very popular still. So later in this course, you probably will see some plus 3D data. For example, the image here is a famous Blunt simulation data defined in a curvilinear grid. So that's it. So I'm hoping that you have a basic understanding of NetCDF and the plus 3D file format. In the future, when you have those files, you will know how to collect information from the dataset.